So we're in our final learning objective, the kind of second set, that one that you need to complete in order to get a 90% A for this unit. All right, so we're going back to the law of sines and cosines. All right, so recall the law and sines of cosines from the earlier learning objectives, so you can kind of go and copy them down. And I'll put them here. All right, so these are the laws. The first one, the law of sines, basically the ratio of the sine of an angle and the opposite side are equal across the triangle. So if we're relating sides and angles, we can use the law of sines. The law of cosines ends up being similar to the Pythagorean theorem, which is that kind of correction term. And just remember that the side and its angle across from each other are kind of on opposite sides of that equation, and those two other sides are in there. So if you have a lot of information about the sides, you'll probably use the law of cosines. If you have a lot of information about angles and things, you'll probably use the law of sines. But for this video, for each one, they're going to be word problems. For each one, the basic idea is you want to try to draw a picture and just see kind of what you can figure out using these two laws or anything that we've done previously. All right, so sometimes you kind of just figure out all the stuff that we've done with triangles, and what can you figure out until you slowly get to the value you actually need. All right, so two radio towers are 20 miles apart. A plane is flying between them. The angle of elevation from one tower is 15 and the other is 35. How high is the airplane? All right, so I'm going to pause for a second and draw a picture. All right, so it's always a good idea for these ones that involve right triangles to draw a picture. So let's do that. All right, so here's the picture we have. We have these two radio towers. The angle of elevation, so one looking up would have to be 15 degrees. The other one looking up is 35 degrees. And those radio towers are 20 miles apart. And we know how high is the airplane. All right, so how can we figure out this part of these triangles? Well, one thing you'll notice is that this piece we're trying to find is actually not a part of this bigger triangle here that's made with the plane and the two radio towers. So we actually can't find this right away. We can't do that because we don't have all the information we need. We have a lot of information about this green rectangle, or sorry, green triangle, but not that blue line there. What we do have is we have a side length and these two angles here. And if we have a lot of information on angles, we can use the law of sines. So we can use the law of sines to figure out this value and that value. Really, we don't need both of them, but you could figure out both of them if we want. Let's just say we're going to figure out A. All right, so the law of sines is going to say if I take the side length A and I divide it by its sine of 35, at the angle across from it, that's going to be equal to, let's see, so we don't want to use B because that's another value we don't know. We want to use 20. And that's across from the angle that kind of this triangle makes. We don't know that yet, but we know that the angles of a triangle add up to 180. So that angle has to be, let's see, 15 plus 35 is 50, so that's going to be 130. And then we can use this to figure out what A is. If I just multiply both sides by sine of 35. That's 30. And that's what you just type in a calculator. And we're going to get that this side length is 14.98 and our units are miles. Right, so now we know A. And how does that help us if we're trying to figure out this blue line, this height here? Well, now we know this angle is 15. We know this side length. And now we can use, kind of going back even farther, just our normal SOHCAHTOA. If I have this 15-degree angle, I want to find the opposite side from it. Now I'm just looking at kind of this left-hand part of the triangle because I'm trying to find that right-hand side. I want to find the opposite from 15, and I know the hypotenuse, which because that's a right angle there, of this. So I can use sine of my 15-degree angle is the thing I'm looking for divided by what I just found. And multiplying x is going to be 14.98 sine of 15. And put that in the calculator. And you're going to get 3.88 miles. Right, so this plane is almost 4 miles high. All right, so you can see the kind of difficulty with some of these problems. So first, you got to draw a picture to see where your angles and things you are. But you always can't get to the answer in one step. And this one we had to use the law of sines to figure out a side length. And then we had to use our normal SOHCAHTOA once we just look at the right triangle that we have to get the final answer. All right, so a lot going on with these ones. Don't be kind of scared to try some things, see what you can use from your triangle. Try SOHCAHTOA, try the law of sines, try the law of cosine, see what you can kind of figure out in your picture that you don't already know. So with that in mind, here's a similar one. A blimp flies over a football stadium, which is 145 yards long. From one end zone, you look up at 70 degrees. The other end is 62. How high is the blimp? All right, so you can see this setup is very similar to the previous one. Go ahead and figure out how high this blimp is. And here's the answer I came up with. So just to be a little different, I found the right-hand side, this A value, using the law of sines. I figured out that this side length here is going to be 172.28 yards. And then now that we know this side length, we can use that to figure out the height using just our normal SOHCAHTOA. So opposite hypotenuse is a sine. Plug all that in, you get 152.11 yards is how high this blimp is. All right, so a boat leaves port and travels straight for 10 miles. It then turns 20 degrees and travels another 8 miles. How far is the boat from port? All right, so let's look at what a picture is going to be first. So this is the situation we have. All right, this boat starts here at port and just goes straight for 10 miles. Then it's going to turn left or right. It doesn't really matter, but the picture will be the same. But I said it turns left 20 degrees. All right, so this little angle here is 20 degrees, and then it keeps going that direction for another 8 miles. And our question we actually want to answer is how far it is from port. So where it started to where it is now, this kind of dotted blue line, how long is that? Well, in this situation, we have more information about sides than angles, and we're trying to find a side. So in this case, I think it's going to be more appropriate to use the law of cosines. Just because we don't have a lot of information about sines. There's probably ways to use the law of sines to kind of break down and get a lot of extra information. Right? But I think the least number of steps is going to be to use the law of cosine. So if I want to find this side here, to use the law of cosines, I need to know its angle that's across from it. And that's not given to us, but we know we had this kind of straight line if we were to keep continuing, and we turned 20. Right? So 20 is missing from this straight line, which means what's left over is 160, right? Because a straight line is 180 degrees. So to take away that 20-degree turn, that angle there has to be 160. And now my law of cosine says this missing side is equal to the other two sides squared added together minus 2 times those sides times the cosine of 160. All right, so that's what the law of cosines says. I can find this missing side if I know the other two sides and its angle. All right, so now it's going to be a bunch of simplifying. Let's see. 160 cosine of 160. Again, I'm just going to use a calculator to plug all that in. So 100 plus 64 minus 160 cosine of 160. 335. And then I want to figure out x, so I have to take the square root of both sides. So x is going to be whatever that square root of that number is. So let's see, the square root of 314.35 is 17.7. 17.73 miles. And that makes sense in the context of the problem because I traveled 18 miles, 10 and 8, but because of that little angle, I know I'm not fully 18 miles away, so I end up being 17.73 miles away. And again, the idea for these, want to draw a picture. When you get to the practice problems, they don't have pictures included. So on the solutions, I drew pictures so you can kind of see what I'm picturing in my head when I'm trying to describe the situation. Sometimes it's hard to do in words, describe it really well. So if you're really confused about the wording of the problem, look at the picture on the solution and then try to figure out how you can use the laws of sine and cosine and SOHCAHTOA. Things you know about angles and triangles and all the things you know together in order to figure out the answers to these word problems. So here's a similar one. You're running on a path for 1.5 miles. you turn 30 degrees and run another mile, how far are you from the starting point? So real similar to the previous one, all right, just running instead of on a boat. And here's a solution I came up with. All right, so really similar, you go 1.5 miles, you turn and run 1, just to be different. I turned to the right instead of to the left. There's really no difference in anything if you, which direction you made that 30-degree turn. Plug that into the law of cosines. I use a calculator to simplify the right-hand side, take the square roots, and you get 2.42 miles. And that makes sense for the problem because total I ran 2.5 miles. Because of that little turn, I'm not that exact distance away from the starting point. So 2.42 miles makes sense. It's a little less than 2.5. All right, so for your multiple choice question, all right, it's kind of hard to give an entire one of these as a multiple choice question. So just something from the past. What is the exact value of cosine of 7 pi over 6? All right, so if you can remember how to do these sine and cosine values, especially if they're not in quadrant 1.